Okay, in this problem, we're asked to find the power factor of the source and Vs of t if f is equal to 60 hertz. Notice that we have a line with an impedance of 0.2 plus j 0.4 ohms. We have two loads. The voltage across those two loads is 480 at an angle of 0 volts RMS. Again, we're going to utilize Telegin's theorem, which says the source has to supply the complex power absorbed here, here, and here. Now, one thing we need to be careful with here is this load we're given kilowatts, this load we're given kVA. Okay. So this first one we're given the real power, the second one we're given the apparent power. I'm going to call this one load 1, call this one load 2. So we have to be careful with the fact that we're given real power for one, apparent power for the other. So for S1, the magnitude of it is going to be the 50 divided by 0.82, and that's P divided by the power factor. So if you remember, S is equal to P divided by the power factor. So here's P divided by the power factor plus cosine inverse of 0.82. Okay. And the angle is positive because it's a lagging power factor. So this is 61 at an angle of 34.92, which in rectangular form is 50 plus j 34.92. Okay. Now for the second load, S2, now we're given kVA, so here this is 50 because we're given apparent power. We don't have to divide by the power factor. Now the angle is minus cosine inverse 0.95, and it's minus because of the leading power factor. So we have 50 at an angle of minus 18.2 degrees kVA, or 47.5 minus j 15.62 kVA. So now I'm going to calculate a complex power for the combined loads. I'll just add those together. So that's 97.5 plus j 19.3 kVA, and that's 99.4 at an angle of 11.2 degrees kVA. Okay, so now we've really rearranged our circuit to be this. Here's Vs. We've got 0.2 ohm plus j 0.4 ohm. The voltage across our load is 480 at an angle of 0 volts RMS. Now, let's calculate this current IL. So S sub L, which is the load, is VL IL conjugate. So we can solve for IL as SL over VL and take the conjugate. So we have 97.5 plus j 19.3. And we need to remember that's all times 10 to the third over 480 at an angle of 0. Conjugate, and that's 207.1 at an angle of minus 11.2 degrees amps RMS. Okay, so that gets us the current IL. Okay, now we can calculate S for the line. It's going to be the magnitude of IL squared times Z of the line. So we have 207.1 squared times 0.2 plus j 0.4, and that's 8.58 plus j 17.16 kVA. Now, by Telegin's theorem, we know that the complex power supplied by the source is S of the line plus S of the load. So we have 8.58 plus J 17.16 plus 97.5 plus J 19.3. That's 106.08 plus J 36.46 kVA, or 112.17 at an angle of 18.97 degrees kVA. Now we can calculate V sub S, because we know, for instance, that S sub S is V sub S IL conjugate. So then V sub S should be S sub S over IL conjugate. So we have 112.17 to the third at an angle of 18.97 divided by 207.1 at an angle of minus 11.2. Take the conjugate. So this is 541.6 at an angle of 7.77 degrees volts RMS. Notice we had volts RMS when we started. All the calculations are done in RMS. Now, the power factor we can get by taking the cosine of this angle. Okay. So the power factor of the source we get by taking the cosine of 18.97 is 0.9457, and it's lagging, and that's the reason it's lagging is the angle on S is positive. Look back at S, this is a positive angle. If this angle had been negative, we'd have had a leading power factor. Now, we were asked for Vs of t. Okay. And we were told that the frequency was 60 hertz. So the amplitude of Vs of t is the square root of 2 times 541.6 times the cosine. Since our frequency is 60 hertz, our omega is 377. Okay, so Vs of t then is 765.94 cosine 377t plus 7.77 degrees.